Thank you, Matt. First of all, thank you for coming here to listen to the talk. My name is John, but the spelling is Can. The reason is in Turkish, C is a J, and that's my name. And yeah, I'm going to talk about a project that we've been working at Twitter for a while, and then we recently open sourced it. It's called Vireo. And what is Vireo? Vireo is this lovely little bird over here. And at Twitter, we love naming things after birds. And Vireo sounds awfully close to video. Therefore, it's called Vireo. What is Vireo? Vireo is a C++11 video processing library. And what it does is it pretty much powers our transcoding service at Twitter, and it's also in deep learning recognition systems that powers the image recognition and video recognition, etc. And then it's in our Android app. So it touches pretty much all the videos that are being uploaded to Twitter. And this includes regular VOD, and then it's also touching Periscope as well. So the good thing is we recently open sourced it in the past December. And you can find it on GitHub. You can use it. You can give us feedback. We would love to hear from you. And what it does is it's essentially a C++ library that allows you to construct custom video processing pipelines. And why you would want to use Vireo instead of the alternatives. And the reasons are, first, it's pretty robust, and we tested really, really well. We've been using it for about 4 years at Twitter in our backend services. And as a C++ library in your backend, if you have memory leaks or if any crashes, it can take down your entire service, and you're susceptible to DDoS attacks as well. And this never ever happened in the past 4 years. We have processes that would prevent this from happening, and you have to bear in mind that the scale that this is being used at Twitter it's touching every single video. Number two is it's not reinventing the wheel. Essentially, it's a puppeteer around all the open source libraries that we are accustomed to using, right? X264, FFmpeg, LSmash, etc. And what it does is it defines a unified API that is a little bit more intuitive, and all these libraries are maintained by different developer groups. Therefore, they have different data structures, etc. And then Vireo essentially takes care of the unification of these data structures, so you can pass an object from FFmpeg and then feed it to X264 or feed it to VP8, etc. And our main focus when building Vireo was performance and memory usage. And the reason is we didn't want the users of Vireo to think about how these underlying libraries are utilized. So we try to optimize the memory and CPU usage in these libraries based on the pipelines that you construct using Vireo. And then number three is it's licensed under MIT. It comes in two flavors. One is a C++ library that you can drop into your code, and then you can construct anything you want. And then another one is we did that for you for specific tasks that are more common for video engineers. So there's a bunch of command line tools that it comes with. But if you look at the left-hand side, the developers, the API is pretty simple to read. It's very intuitive. It's like you have the input file, you pass it to the demuxer, then you pass the demuxer into the decoder, that into encoder, the muxer, and then you have a file. And this is actual code. This is not pseudocode. This is the code that would transcode an MP4 file to, or any video file to MP4 file. And this is the address. So please go and check it out and use it, try it, give us feedback. I'm sure you'll find bugs, do bug reports or send us PRs. And if we have time, I would like to do a live demo. Yeah? Cool. So this is the GitHub project page. And this is a typical, configure, make, install type of compilation process. I've already done this, so you don't have to watch it. It's not that long, but I just don't want to spend any time on that. So I'll just go with the make install, which will put it into my build directory. So essentially, we have all these tools that we built. So let me run some of these tools. The frames tool is a metadata inspector. So it tells you things like the samples in the video, essentially what's contained in the container. It doesn't do any decoding. And then there's a transcode tool. So it has a bunch of parameters that you can set that takes in an input file and then gives you an output file. And then we also have this hello world example where we have this C++ file that allows you to drop in Vireo as a library and then use it in your code. And then this is an example C++ file where we do that for you. So let's use one of these tools and inspect this file that we have here. If you use frames tool, it gives you things like the width and the height and the pixel aspect ratio, duration, etc. And you can also ask for sample-specific information to it. So it tells you how many frames there are, the GOP structures, which frame is a key frame, and then the timing of them. And then one really useful thing that we found is for MP4s, there was no tool that showed you explicit, OK, these are the edit boxes, and this is what we built into frames. So it tells you how many edit boxes there are, et cetera. And then this timing information is calculated based on the edit boxes inside the file. So let's do another thing, which is let's actually come here. So this is a C++ file that's inside that folder. It's pretty simple. It has 3 functions. One remux function that takes in a movie file and then converts that into an MPEG TS file in the output without transcoding. And then we have keyframes, which takes in a video file again, and then it filters the video track and then extracts only the keyframes and then packages back into an MP4 file without transcoding. And then we finally have the transcode example that I had in my slides. So let's build this. OK, and then let's run it. So now it generated all these files for us. OK, this is the remuxed file that came from the first function, TS. And this is the keyframes, which extracted just the keyframes and then repackaged it. And then this is the transcoded. So let's do one more thing, just to confirm that it indeed did what we said it did. And then let's look at the keyframes file and then inspect it with the frames tool. So as you can see now, the GOP structure has changed. Every second, we have just one keyframe, and then it's one frame only. And that's it. So yeah. GitHub page, go to it, check it out. Let us know what you think. Thanks.